All right, there we go. Okay, everybody. Well, welcome to Portland Urban Beekeepers June 2023 member meeting. We're so excited to host Robyn Underwood this evening, who's going to talk about organic beekeeping, and Glen Andreson, who's going to talk about the pollen and nectar flow. We want to remind everybody to continue to support PUB and get your friends to support PUB. Our membership includes a great swarm list, which I guess we've had a lot less swarms reported in Portland this summer so far. But we also have the Bee Buddy program, which is a map, a Google map, which charts beekeepers by address. And so you can see which beekeepers are in your area, and on that Bee Buddy program, you can sign up as a mentor or a learner. So it's really helpful. We have bee days at the apiary. That happens twice a month, and it's been really great out there. They recently had a successful grafting project of queens, and so all kinds of fun things are happening out there. Remember that we have a library hosted by Katie Fackler, and that includes books, candle molds, DVDs, etc. And we have a great equipment rental section. We have extractors, refractometer, observation hive, and a frame jig. Our annual membership is $25. Upcoming speaker lineup on the 12th, we have Fanta Monlignon. Did I pronounce that right? Monlignon. She's going to be in person and Zoom, and she's going to talk about inspections and brood nests. And of course, if you have a speaker suggestion or topics that you want us to look at, please email the president at portlandurbanbeekeepers.org. On Saturday, June 14th, that's this Saturday, between 2 and 4 p.m., we're going to be at an event called 1% for the Planet, Bees and Beers. That's going to be an amazing afternoon at Oak Union Brewing, and we're going to get to sample their newest brew called Spectral Mist. And PUB is the proud recipient of their 1% for the Planet contribution for all sales of this beer. The brewers will be joining us, so this is an event not to be missed. It's at the Proper Pint Tap Room, 5965 Southeast 52nd here in Portland. In case, for those of you that can't follow along, that are not able to read the screen, I'm going to read Robyn's amazing bio for us really quick. Dr. Robyn Underwood was born and raised in Pennsylvania. She studied entomology and applied ecology for her BSc from University of Delaware, New York, Delaware, where she fell in love with honeybees and beekeeping while taking a course in apidology with Dewey Caron. She went on to study honeybees further by researching the use of formic acid to control parasitic mites in colonies kept indoors for the winter at the University of Manitoba in Winnipeg, Manitoba, Canada, where she obtained her PhD. She returned to Pennsylvania and continued conducting applied research while working as an assistant professor of biology at Kutztown University, and later as an assistant research professor at Penn State University. Her research and extension work has allowed her to interact with a large network of beekeepers from across the Commonwealth as stakeholders, advisors, and students. So without further ado, let's welcome Dr. Underwood.
Thank you. Yeah, since then, I have become Pennsylvania's extension educator for apidology, so apiculture, whatever you want to call it. So I finally, in my later 40s, landed the dream job that I always wanted. So I get to talk to beekeepers and learn from them and visit them and talk about bees and all the time. So it's really exciting. And so what I'm going to talk about tonight is a project that we've named COMB, and it was a research project funded by USDA NIFA OREI program, which is organic agriculture. And we have finished this project. It was a long-term project and it is published. So that's very exciting. When you start off, you have all these grand plans, and then when it's finally on paper, it feels really good. So I'll be sure to share that with you. So, as you know, as a beekeeper, there's a lot of stressors on your bees all the time. Um, Many of them you have no control over, like what is the forage around? Are there pathogens in your neighbors' colonies, etc. But what I feel very strongly about and passionately about is beekeeper practices. So, you as a beekeeper are making choices every single day about what to do with your bees, how to treat them, whether to treat them, how often to monitor, your skills as a, disease identifier, like we're our own veterinarians for our bees. And so the beekeeper plays a huge role in the life of the bees, in my opinion. And so, um, for me, when I go to a beekeeping club and chat with the people in the audience, I find that there's a lot of different types of beekeepers. People that aren't beekeepers think that beekeeping is one thing, and it's so many different things, right? And your philosophy matters. So we have been talking for a few years now about people's beekeeping philosophy. So if you think about it, a philosophy is sort of your attitude or how you think about things. What is it? What are your guiding principles for how you behave? And if you think about your beekeeping philosophy, it's like, well, what is my role in the lives of these bees, right? Am I just going to let them in the box and see what they do, or am I an active manager of those colonies, and or am I something in between? And so we actually published a paper about beekeepers, which is quite unusual because I'm an entomologist, not a sociologist or something like that. But Margarita Lopez Uribe and I really wanted to be able to talk better about beekeepers and their philosophies. And also, when I have gone to introductory beekeeping classes, I feel like people come in with sort of a philosophy, and then they look around and they see these beekeepers teaching this class, and they're just not really sure where they fit in or which mentor would be best for them. So we made this sort of continuum to help people describe themselves or figure out how they fit in. So what you're looking at here is what we call the beekeeping continuum. And from left to right, we go from low intervention to high intervention. And then we have a list of a whole bunch of different choices that beekeepers are making. So if you look at the first section here at the top, uh, where do you fall in terms of chemical use? The first line is about varroa mite treatments. So if you do not ever use any chemicals in your hive for varroa mite treatments, then that's the lowest possible intervention, right? You're doing nothing. If you're using essential oils like thymol or oxalic or formic acids, you're kind of like medium to high-ish. And then the highest, I think, are the synthetics. So that would be your amitraz, not only because it's a 42-day treatment and then 2 more weeks before you can put your honey supers on, but amitraz can contaminate your wax. So it doesn't go in as actual amitraz, it goes down in as some breakdown products, but they're there kind of forever. So that's pretty high intervention to put in a chemical that stays. Then we can move down to, hive manipulations. Will you do nothing? You just put them in a log, or are you going to have a traditional hive with a screen bottom board? Are you going to have a brood break to try to, affect the varroa mite life cycle by affecting the bee life cycle? Or are you going to simply use small cell comb? That is the highest intervention for me because you're fundamentally changing the architecture of the hive and the size of the bees. Does it help with varroa mites or not? That is in question. So anyway, if you go to the site where this paper is published, it's free and available to everyone. You can actually download this figure and print it out, full size, so you can actually read it. And I would encourage you to do so. And what you can do then is circle the things that are you, right? So where do you fall on the continuum for each of these lines? So here I have an example of what that might look like. So in this particular figure, you can see that this beekeeper is willing to use essential oils and some acids. In where we are, small hive beetles, nosema, and the need for antibiotics are minimal, so generally not used. Um, Plus antibiotics, take a veterinarian, so that's usually not our choice for how to react. This beekeeper uses drone brood removal, like a mite trapping technique. They're not going to be replacing their queens unless they actually need to, like for a real reason, other not just they're getting old in the beekeeper's mind or it's fall or whatever, et cetera, et cetera. And so what you have now with this printed paper and your thing circled, you have what we call your management system. So you don't just have management for one of these lines, you have all kinds of different choices. And I'm guessing that you probably do the same thing year after year. It's kind of like if you're established enough in beekeeping, you've done this for several years, you figured out what works, and you continue to do that. And probably for the first line, you've decided, well, I really need synthetics or I'm going to avoid synthetics. That's part of your philosophy. But overall, we like to think of this as a system. This is a honeybee colony management system. And so if you look at your system, you probably fall vaguely into one of these three categories. You may be considered a conventional beekeeper because you circled things like you're willing and you sometimes use synthetics for varroa mites or antibiotics in your hive. If, on the other hand, you were just like what I circled, you are not using synthetics for mite control, but you're using, Thymol or one of the acids, and you're not using any antibiotics, you actually fall into the organic category. And then at the bottom here, we have what I'm calling chemical free, because that's what we called it for our paper. You might call this treatment free or all natural, or there's all kinds of names for not ever wanting to put chemicals into your hives. And so for this paper, we used Bee Informed Partnership survey results from the year, I think it was the 15-16 winter, where they had this huge long management survey that people could fill out. And so we were able to purchase the data from Bee Informed and analyze that one year. And so for the next few slides, you're going to see a figure that looks like this, and there's going to be dots all over when I click my space bar. And the dots each are one beekeeper. And in this particular graph, the beekeepers are lumped by their philosophy. So they're either an all natural or chemical free beekeeper, organic or conventional. And these are the colors that you're going to see throughout this whole talk. Natural, chemical free is always like this red, orange, organic is green, and conventional is blue. I mean, I'll always say that, but you can train your eye. So this particular diagram is about what you're feeding to your bees. So what we can see here, to summarize, we have all the way on the left are beekeepers that happen to be conventional, and those beekeepers are, artificially going into the hive, giving them pollen patties, early in the season. They're willing to feed carbohydrates that aren't honey usually, right? Because you're selling the honey, but even high fructose corn syrup, for example. So that's why it says any carbohydrates. On the opposite side, we have the chemical free or all natural beekeepers who aren't really giving them protein because they want to match nature, and they try to leave behind tons of honey because that's what is best for bees. So this next graph is dots again, same colors, but this time it's about what are the goals of the beekeeper. The goals are really important to what your management decisions end up being. So in this case, if you're acting as a conventional beekeeper, by the way, this is totally based on the management questions from the survey, it's more likely to be people harvesting honey for profit and possibly even selling bees, right? So they're going to sell off nukes or queens or something like that. And then all the way on the right, the all natural beekeepers may not harvest honey at all. They probably have bees just for teaching or for pollinating their own garden, something like that. So this is pretty interesting, the way they're like kind of spacing out together. So this time the colors look the same, but it's actually a different code. So this time it's based on the size of the operation. So we have backyard beekeepers for this, that would be less than 50 colonies. Then we have sideliners, so 50 to 500, and then commercial is more than 500. I don't know what it's like in your state, but in Pennsylvania, 98% of us are backyard. Like, so anyway, let's see what these people are doing based on the size of their operation. Well, the circles have changed, right? You can see the commercial beekeepers with over 500 colonies are real tight together. They're all kind of doing the same thing. They're willing to use antibiotics. They're using synthetics for varroa mites. They're prophylactically treating for nosema. All these things on this large scale. Then if you look at the red, which is the backyard beekeepers, they're doing all kinds of different things. Some of them are acting like commercial beekeepers. These people on the left are doing just what commercial beekeepers do, but they have maybe 10 colonies. And then other people way, way different from a commercial beekeeper. So this is just super fascinating to me to think about, you know, as a hobbyist, how are you making these decisions? What are they based on? Why are you doing this? Have you thought about what's best for your bees? Do you know that, your choices are good? And also, of course, this is all about time and money, especially for commercial beekeepers, right? So anyway, when I go to clubs, mostly it's hobbyists. There's a few sideliners, there's commercial guys are not like coming to your club. They're not probably on this call. Forgive me if you're a commercial beekeeper and you're on this call, but I doubt it. They're almost too busy. They're dead asleep right now. Oh, it's only 6 o'clock, still light. They're working, still working. So we studied the beekeepers. We had our own experiences where we kind of knew there were these groups, right? And so that the data showed that they do fall out into 3 groups and their management decisions do match the type of beekeeper they think they are. And so then we had to ask ourselves, every beekeeper wants to do what's best for their bees, but what is best for the bees, right? Which one is the most successful with the healthiest bees making the most honey? And so we started off with this research project. We acted like full-size honey producer, sideliner beekeepers. So we didn't move them around for pollination or try to make money off of that. We just kept them in place for 3 full years, and they were literally side by side. So we had each apiary, and I'll show you a picture, had 12 colonies. 4 conventional, 4 organic, 4 chemical free, all inside of the same bare fence. So literally side by side, because apiary matters. I don't know if everyone's like, why don't you have an organic one over here and a conventional one over there? Like, well, they could have all died over there because of wind. And then they would have all been conventional and we would have said, oh, conventional is bad. So we had to have them literally side by side, same food sources, same wind, same cold, same everything. So we set out to make management systems. So a lot of research does one thing at a time. You use formic or you don't, or you have like 3 doses of formic or none. This was like a whole systems approach. So we didn't want to just be like, the professor in the lab, in your office trying to say what beekeepers do. We actually asked them. So we had this event where we invited the most respected beekeepers across Pennsylvania all to come together for the whole day and hammer out these management systems. So it was really funny when we went to take this group photo, the people stood in their groups. Like there was mingling before this, but they were like, let's line up. And like here on the left are the chemical free, middle is conventional, is organic, and on the right is conventional. So it's really funny. I don't know if you would recognize anyone on here, so I guess I won't go through it, but this is Marianne Fraser. She was with Penn State before I joined, so she has quite a legacy of fact sheets and things like that. And this is Margarita Lopez Uribe, my close collaborator. So we sat them down and we asked them to go through and tell us everything. Like we were buying all new equipment, new bees, new foundation, everything. And so they had a chance to make it right. And part of the reason of doing this was to, really do what they're doing. But in the end, they ended up being our biggest advocates. They were talking about this project all over the place all the time, right? And they really understood it because of thinking about this systems approach and being part of the project. We would meet with them privately. like every 6 months and tell them, update them and ask their advice for moving forward and make sure that it all made sense to them. So they were a huge part of the project. Okay, so I'm going to go through and tell you all the nitty gritties of these management systems. I have it in table form. I'll describe it. And then we have this diagram that we ended up putting in the paper that really sums it up. So you don't have to memorize this, of course, but I want you to kind of think about the systems. So on the left is conventional, middle is organic, and to the right is chemical free. And so when we began, we used, of course, 10 frame Langstroth equipment, and the comb was plastic foundation in a wooden frame. That's our preference. As scientists, I know that a chemical free person probably is not using the plastic. It is allowed for organic, but we wanted to force the issue of comb size. We didn't want them to be able to take wax and change the size. So that's why we went with plastic. But conventional and organic colonies got standard foundation that you would get if you go to the store and just buy foundation and don't ask for any particular type, which is about 5.4 millimeter hexagons, and chemical free got small cell. So that's what we call this, 4.9 millimeters. And I did, after they built out the comb, did measure it, and they did a really good job of keeping it into those sizes. Some had screen bottom board, others had solid. Conventional and organic, for the most part, were avoiding drones like most beekeepers do. But in the organic treatment, one of the frames in each brood nest box was a drone frame, the green ones, and we used that as a mite trapping technique. So every time we visited, which was every 2 weeks, we would scrape off the capped drone brood and hopefully be removing mites at the same time. In chemical free, they want to do what's closest to nature. So when we actually had to make the wooden frames with plastic foundation for chemical free because it didn't exist. It was either all plastic or standard foundation. So we had to take the all plastic frames and cut them to make them into foundation. And we left 1 inch on each side just totally open so that the bees could choose what to build in there. And by and large, they built drone comb in there because they really want to have drones. So for the conventional with all standard comb, we're really going against their natural instincts. I learned to love these wintering covers. So if you don't know what that is, it's basically a wooden inner cover with a spacer, like all built together, and is so useful in the bee yard. When it's upright, you keep the lid out of the center. Well, if it's in, it's fine, but the ants live up there then. So if you just leave the bees access, they keep it clean and they don't build comb in there. Turn it over though, you've just given them space to build in. Or it's a candy board for winter, or it's a spacer with a treatment. It was just really, really nice and versatile. So anyway, for chemical free, they were quite insistent as being as close to nature as possible. So not only was their inner cover made of cloth, so it was cotton duck cut to the size of an inner cover, but also the insides of all the boxes got all scratched up because we wanted them to build a propolis layer like they would in a log hive or something like that. And they totally did. I have all these awesome cloth undercovers that are like stiff as a board because they just propolized them in stripes, with the frames. So, okay, so that's the physical equipment. And then what did we do for treating for varroa mites? These all started as packages. So when they arrived, we did an oxalic acid dribble on these two, but really almost no mites fell. In fact, we tried to do a little research project with the mites falling down to the sticky board, and there weren't enough mites to do anything with. So it's disappointing, but also refreshing because a few years before that, people were getting packages just loaded with mites. And so I think the package producers caught wind of that, all those complaints, and decided to do something about it at home rather than when the beekeeper arrives with the package. But anyway, so we wanted them to start with no or low mites. And then throughout the season, we would do an alcohol wash every month. And if they hit our 1% threshold, which to me was really, really low, and I didn't think we could keep it down, but you'll see that we did pretty well. If they hit 1%, we would have had to treat, but none of them did. But in the fall, which to us in Pennsylvania is like late August is time to do your fall treatments. Not past the first week in September. After that, it's too late. So early fall treatments. So conventional, no matter what their mite counts, got amitraz strips. Organic, no matter what, got Formic Pro. And of course, chemical free is never going to get any chemicals. And then we give them a little Christmas present of an oxalic acid vapor as a cleanup, unless you're chemical free. And then there was certain, like, everybody had 60 pounds of food in the comb before October, and then also got some emergency winter food, which would have been either a candy board with 3% protein or sugar, just sugar out of the bag. Okay, so that was year 1. In years 2 and 3, we had to treat more often. So you know that a mature colony is much different from a package building its own comb. And so then we did like we had plans for what to do when. If you hit 1% in this apiary, you should treat with. And so there's a bit of a, oxalic acid early, then we switched to formic, and then we switched to something for the fall. So for conventional, we always use the amitraz in the fall, no matter what. For organic, we were really interested in integrated pest management and rotating chemicals. And so they could get formic up to 2 times, never 3, right? So if they got formic already and fall came around, we would give them Apiguard Thymol gel treatment. But if they hadn't gotten formic, they would get formic. So what actually ended up happening is in so year 1 on the previous slide, everybody got formic because that was like their first treatment basically. In year 2, everyone had definitely had formic in the summer, so they ended up all getting Apiguard in the fall. But by the 3rd year, it varied by apiary, whether they had formic already or not. So it's pretty interesting dynamic to see over time. Okay, let's summarize this. So here we have our 3 management systems in a figure. You can see that we used frame feeders, which I just left in all year long because I'm super lazy and I don't want to like put them in, take them out, store them, bring them back, put them in, take them out. They're just in. Either they're full or empty. I don't really care. Never full going into winter. It's bad to have, a jug of syrup next to you, but that's how we fed. And then you can see here with the drone combs. And yes, okay, I used all mediums. I'm still getting a hard time for that, but I really like using all mediums because I can move the frames around and do whatever, move them up and down and encourage the bees to go to the next box and all those things. But you should know mathematically that 3 mediums is just the same as 2 deeps. So this is basically double brood chamber management. And here we have our chemical free with the 4.9 foundation and the spaces on the side. And then this down here is just our timeline that I just explained about the when to treat with what. Okay. I hope you have that all memorized and know everything about everything. All right, so here's Pennsylvania. We also had a collaborator in West Virginia. I don't know if you ever heard of, there's this Appalachian beekeeping collective. They give out of work coal miners a job by teaching them how to be beekeepers and sell their honey and stuff for economic development. And they were starting 1,000 new colonies. So they were like, hey, we want to do research. Why don't we do some just like you? And then we're extra replicates. We're like, yes, absolutely. More the merrier, more colonies, please. So each star is a farm. Each farm had 3 apiaries of 12, and each apiary had 4, 4, and 4. And the order of those 3 was different in each one. So that in each region, so here in Pennsylvania, if we call this the Northeast, every configuration is represented. There's 6 possibilities of the 3 next to each other. And instead of putting like in a straight line and having lots of drift, they were each on their own hive stand and they were in these little arcs to try to like keep them, within themselves. So this project started in April of 2018 when we had packages arrive and we put them into that new equipment that was all out and ready for them. And we monitored individual numbered colonies over time for 3 full years. So they went through 3 winters. Now, of course, packages, you're probably already like, oh, they just got packages and then just didn't treat them. Of course, I know what the result is already. We never expected, Georgia packages to be able to live chemical free because they're from the chemical system. So we requeened every single colony with the best genetics that we could get our hands on en masse for our region. And this was our queen breeder in the Poconos of Pennsylvania. And he made us sister queens. So every colony in the whole project was requeened with a sister. So we did not want genetics to affect any of our results. We wanted only management. So we had to requeen all of them. And so that's what you can see here, one shipment of queens. So it wasn't easy. Some of them took 2 or 3 tries of queens, we had to get extra, and but we did it. And so that was the first summer, so that they had several generations of workers before the winter. As I said before, every month from April through October, we would do an alcohol wash for varroa mite population status. Every fall, we wanted to understand like a snapshot in time to see how they were going into winter. So after all the treatments were over and everybody was done, was all set, we would take a varroa wash, bees in alcohol for nosema analysis, and then a whole bunch of bees into dry ice for other lab tests of viruses and their immune systems. Because it was like the snapshot, okay, now they have to go into winter and survive. Let's see who's the healthiest, and then we can compare it to who actually survives. Of course, we also were really interested in honey production of the different treatments. So this is my honey with my cute little label. We sell this in at Penn State. There's a creamery. It's like a major hub, and they sell my honey there, and then I get to put the money back into research. In fact, for our new project, we didn't have money for bees, so I got to use honey money for that. So everything's paying it forward. To do this, we very carefully had to label every box and every frame every time we extracted, and weighed the box before and after extraction. So the weights are really extracted honey that's sellable. And of course, overwintering success is everything. You can't do much with a dead colony in the spring. Okay, so I have some major summaries to share with you. This is over the 3 years. Most of these graphs combine the 3 years together. And what you can see here is that there's this pattern of A, B, B. So that's the statistics showing you that chemical free is different from conventional and organic. Conventional and organic were not different from each other. So really these two management systems made more honey than the ones that were chemical free. And numerically, there's a bit more made in organic colonies, organically managed colonies, than conventional, but it's not statistically significant. So what happened with the mites? Well, what you can focus on first here is the blue and the green, the organic and conventional. Remember I said we were trying to keep them at 1% or less. We did a pretty good job. There wasn't a lot of times when they went over. So the mites were very well kept under control. In chemical free, you can see that each fall, the mite loads would increase. And then in the second year, it was even much worse. Now, a lot of times people ask me, well, why did it go down for spring? Well, the ones with a lot died. So the only ones that were left didn't have a lot, right? It's not like the mites got controlled in the winter. They just killed the colonies, right? So what I want you to notice here is that in the first year, they only got up to about 4%. I was really not worried about them going into winter. I'm like, 4%, that's not so bad. This, of course, these are horrible, but 4%, I thought, So this is just showing you now, because the data really are the snapshot from the fall. So this is what they had going into winter. Here's your, about 4%. And you can see large populations here compared to the ones that we use chemicals to control. So what did this mean for overwintering? Oh, for viruses. Well, you can see this ABB pattern where colonies in the chemical-free system which had lots more mites, had more deformed wing virus than the other two. The nosema results are kind of perplexing to me. We didn't really do anything to try to control nosema. We didn't give them any food additives or anything like that. But you can see that in this management system, chemical free had the most, I think probably because they were the most stressed. Organic had the least, but here conventional wasn't different from either one. So that's, I'm not really sure how to explain that one. But we do actually have samples from spring, summer, and fall that is going to be another paper where we give all the nosema results and the seasonality and things like that. I don't know what they look like yet. I haven't looked at those results, but maybe we'll get an idea then. So vitellogenin is an immune gene that's sort of a look at nutrition. It's also made by the fat bodies, which you know is what varroa mites are feeding on. And so on the one hand, I thought that this would be a result because all the bees had access to the same forage, right? So there's not really nutritional differences. However, the chemical free did have a lot more mites feeding on them. So I thought maybe their vitellogenin levels would be lower, but they were not. There's no differences here, no significant differences. So people in our lab were also really interested in the immune systems of bees. And so this is not my thing. I'm totally into management. I want to be out in the bee yard. Like I'll collect the sample and give it to you and you can tell me what it means kind of thing. So there's several now in a row that are going to be immune genes. And basically a higher bar means that a gene is upregulated, which means it's being expressed more. And to me, I just think of it as your immune system being more like excited or active. So you can see here that the chemical-free system caused an increase in the immune system reactions in the bees compared to conventional and organic. That means our immune system's working hard. Here's another immune gene, same pattern, different immune pathway, and yet another one. You can see this ABB, ABB, ABB all over the place. So it's kind of, you know, everything is pointing to the conventional organic systems are different from the chemical-free system. So how well did they do over the winter? I really like showing the 3 years, mainly because the pattern is so consistent. And we had really great overwintering in both the conventional and the organic management systems. You know, they do the surveys every year. And during this time in Pennsylvania, the survey was showing 40 and 50% losses on average. And we were only having 15 or less percent loss. So these are really good management systems, keeping on top of things and treating when needed. They all can help you have better overwintering. Being a treatment-free or chemical-free beekeeper means you're going to have high losses. Like you're not controlling mites or viruses, and immune systems are getting aggravated, and so survival is pretty low. The first year we had, like 37% survival. And remember, this is a longitudinal study, and we're like following individual colonies over 3 years, and we only had 37% left after 1 year. And so the numbers go down and down. And you can see that in this graph. So we started with 96 in each treatment, and for the chemical-free, by the third spring, we had 1. The others also had losses, and we did even have, summer losses, and that was generally due to, a split or a swarm would fail to requeen, and we weren't going back quite often enough, and then they'd become laying workers, so they were, quote, dead. But really, these two tracked each other, did quite well, and chemical-free was, like a death sentence, basically. So this crazy diagram is a summary of all of those results. So what you're looking at here, the light arrows are a positive effect, the dark ones are a negative effect, and the fatter it is, the more of an effect it has. So basically, because of that ABB pattern everywhere, we saw that conventional and organic were pretty similar to each other. And so this is showing that conventional or organic compared to chemical free had a positive impact on survival. So if you're going to be a honeybee colony, you want to be in one of those two treatment groups, right? You don't want to be in the chemical free treatment group. So what did it mean to be in one of these management systems? This system and the things that you do have a large negative effect on varroa mites, a negative effect on nosema, which by the way is now called viremorpha. That's why there's a V. It had a negative effect on deformed wing virus and expression of immune genes, right? So that's all good. And so if you were able to measure these in a colony, you would see that fewer mites means better survival, less nosema, better survival, less virus, better survival, etc. So in summary, conventional and organic were both excellent management systems with healthy bees and high overwintering survival. So I just want to remind you that our goal for this was to keep stationary, full-size honey-producing colonies. In that case, you have to monitor for mites and control them when they get over a threshold. I'm not saying that everyone has to control mites. I'm not saying that every colony has to be treated, but it's, I think, irresponsible to not monitor and then do something when you know there's a problem. If, for example, you're a queen breeder, it would be silly to just be treating all the time, right? Because you can't see what the bees can do. So people sometimes walk away thinking that I'm saying you have to treat or whatever, and I'm not. I'm saying if you want to have full-size honey producing colonies, you need to be very careful and monitor for mites. And yes, when they get over a threshold, you need to do something about it. You can't just ignore it. However, your choices for what to do can, is personal. And from these graphs, to me, I don't see the need at all for the synthetics. We did a very good job with the organic chemicals, which include oxalic acid, formic acid, and thymol. Hopguard's in there too. We didn't use it in this study at all. There's other things as well. We only used one cultural control, which was drone brood removal. We could have also added a brood break, a screen bottom board, etc. We didn't in this study, but we could have. So in my opinion, the organic management system is the best one because it kept really healthy bees and it avoided all the synthetic miticides. And we have data to back that up. So if you're interested in this management system, I do have a fact sheet online that is literally says, for this project, this is what we did, and it outlines the whole system. As an extension educator, I'm kind of told that I should just tell everybody all their options and not tell them what to do. But so many people want to be told what to do, right? They're like, can't you just give me a calendar and tell me what to do this day and this day and this day? So this is as close as I can get to that. I can tell you what we did for this project, and you can look at the results in our published paper and feel good and think that you can do it as well. I think it's, for a beginner, a great start. And then once you have success overwintering, you can then tweak the system. Like maybe you absolutely hate that drone brood removal. So just like, don't do it. It's fine, but still monitor and treat and use these, organic chemicals, etc. So I just want to thank the many, many people that helped me. I'm sure there's missing names from here. I'm really glad that we got the funding to perform this research. It changed my life and my career, and I'm pretty stoked about the results and really glad they're published, and I hope that you find them valuable. So I will take questions. Thank you,
Dr.
Richard, for
Underwood,
putting the link. Go ahead.
Yeah, I'm wondering, this is fascinating information, and I love what you said in the end, because you talked about beginning beekeepers, which I think is an important demographic for us here at Portland Urban Beekeepers. What's your strategy for engaging those beekeepers with this kind of information? How do you make it actionable? I mean, I think you're right. I'm the same way. I want people to tell me what to do. And I keep getting resistance from that. And as I get further along in my understanding of beekeeping, I understand why, because there's no real one way to do it. But I'm wondering, what are your communication strategies to beginning beekeepers?
Um, so when I joined Extension, which was just last year, February, I finally, I got this position full time. Before that, I was a researcher doing Extension just to share my results. I pretty much decided that my job, I don't want my job to be getting people into beekeeping, right? Because in Pennsylvania, we have 37 local clubs. So they're the ones that are teaching the beginners. I do help with my local club. I give like 2 of the lectures out of the 8 hours of the beginning beekeeping class. One of them is biology of bees, which is just all fun. And then I go over all the different diseases and how you can manage them. And so I really hope that beginning beekeeping classes go through all of that, because you need to recognize all the different problems that you can face in your colonies. So I want beginning beekeepers to understand that it's hard, that they have a lot to learn, and that they should use their resources to identify their problems and then get advice for how to handle them. If someone doesn't have a mentor, though, they could pick up my document and try it, you know. But if someone asks my advice, so as an extension educator, I'll be like, well, you have these 6 choices, but then I'm allowed to say, but if it were me, I would, So I had to use Amatraz for that project, and I not only don't want to use it again unless I'm forced to for research, but I got rid of all those drawn combs, because other people didn't care. And I was like, I'm going to go all organic from now on. So I'll sell you these drawn combs, or you can just trade me for new. And, but so I don't find it difficult to teach a new beekeeper the organic management system, right? What I find difficult is to get treatment-free, all-natural beekeepers to understand that not monitoring for mites and doing something about it is not the best way. I don't know if anybody here is a treatment-free beekeeper, but what you saw there was that they get really sick. They have lots of viruses. And what I'm not saying here is these viruses, if they get really high, they spread to the surrounding area, which is other bee species, which is a problem. And also, I hope you're noticing that I just keep calling it organic honeybee colony management, because I am not saying if you do this, you have certified organic products, right? That's a totally different thing. But what I did in the management system does fall under the organic recommendations, which, by the way, are online, just National Organic Program, apiculture, and you can find it for yourself. One of the really important things in there is not only like no synthetics, no antibiotics, whatever, no GMO, but animal welfare is a huge part of that, right? So it specifically says you cannot, let your animals move forward with a known pest problem. So that's where the treatment-free thing does not line up with organic. So that's something really hard to tell people, because they think that they're being all natural and good and good and good. And I'm telling them that there's something a little bad about it. All I can really do is make suggestions. I don't really know if they go home and change. But yeah, you can't just have your head in the sand and say, I didn't see any mites. So I'm like, well, where were you looking? Like on their thoraxes, or did you actually do some kind of test? Sorry, that was a long answer.
Thank you.
Did I actually answer your question?
Yeah, I'm wondering if you're an advocate for organic treatments and you've come out against treatment-free. I mean, here, oftentimes I'll talk to people that visit our apiary on the side, and I'm hearing more and more of these, I don't know, I call them conversion stories, where I started out with this process and these goals and these desires. And then I was losing colonies and I got a mentor. So now here I am learning how to be an organic beekeeper with treatments. So I'm just hearing more and more of that. And oftentimes that word or that phrase mite bomb comes up. I think it was Randy Oliver that talked about it. And so some people are becoming aware that untreated hives in their neighborhood are affecting our treated hives. And so it's you're right, it's a weird and difficult situation to be in when you want to.
Yeah, and you notice I didn't even bring that up. I have other concerns first, to be honest with you. Like those bees are hurting, right? Have you ever seen it, like full-on parasitic mite syndrome, where like the bees are all deformed and their larvae are looking like snot, and it's just a really sad sight to see. So that can convert someone, I would think. But I also worry about the native bees around. And we were just talking to a collaborator who, because we have these 3 years of like every month we have a varroa mite wash, we're going to try to do some sort of spatial thing. Like if there's a high mite colony in the apiary, does that mean you also have higher mites than a different apiary where there isn't one? So it just took us a while to find someone who knew how to do that type of analysis. So maybe that may be forthcoming. Hopefully something interesting will come of it. But the thing, like, people were like, how could you have them side by side? Didn't it automatically put all the mites everywhere? I was like, it wasn't a problem, because for conventional and organic, we were monitoring and treating when they hit a threshold. So whatever happens, we would catch it within a month. So even if there are mite bombs, if you're a responsible beekeeper, your bees should be fine.
Interesting.
And by the way, check again in October, right? Don't just like put your fall treatments on and be like, oh, I'm all done. No, check again. Please check again. That converted a lot of people, actually. They were like, oh my God, I can't believe how many mites there still are in here. And it's partly due to the brood disappearing. But still, this is like, these are the mites that your bees are going into winter with. So check after the treatment. Eric, I see your hand up.
Yeah, thanks. Great presentation. I like all the side-by-side comparisons. That's really effective. I had a question. You mentioned that you, I believe it was just on the treatment-free segment, that you left some of the, it wasn't fully framed or fully foundationed, and so you let the bees kind of do that. Was that only in the one group, or did you do that in others? Because I do that on, I've got a hive I designed, and every frame I leave some that just lets the bees kind of make whatever they want, either on the top or the bottom, just depending on how I'm cutting the foundation. But I do find that it's effective in letting them do that. And if you are, sometimes I'll intersperse a completely empty frame with no foundation with ones on the other side. So it kind of corrals them a little bit. But did you find any benefit to that as part of this study, or is that just something that you did without kind of thinking that that was a factor?
Yeah, I mean, when we had those treatment-free beekeepers around the table, by the way, I do understand that there's actually like a whole entire spectrum within each of those groups, especially in the chemical-free, treatment-free. Like they could hardly agree on even a single thing, but they had to that day. They just really wanted the bees, they wanted me to probably be foundationless, right? So the bees could literally do whatever they wanted. But we were like, the one thing we can't compromise on is we want to be able to say comb size. So we insisted on the plastic. So they were probably disappointed. But yeah, we just left an inch on each side and let the bees do what they wanted. And it really, I don't have any numbers, but they didn't really put drone comb anywhere else. You know, it was like it gave them a place for it. I mean, sometimes they just filled it with honey too, you know, but every frame in the whole colony had that, supers and everything. They were all the same.
Right.
But all the other colonies had standard, totally standard.
Full foundation.
Yeah.
Okay. Cool. Thanks.
Sure.
And also I wanted to find out that chart that you made, that will be available for download or printing or something, because that's my wife's not here right now, but she'd probably like to see that just to kind of get a sense of what we're doing, you know.
Yeah, I
I
did.
didn't see it on the website or the link.
Yeah, when you look at the paper, I would recommend, if you find the journal article, the philosophy one, download the full PDF, and that's where you get the best quality figure. And if you have any trouble, just email me. I can send it to you.
Okay, thanks.
Yep. Someone's repeating my words over here in the chat. In their own words. Do you think the most promising path forward? Yeah, people ask me all the time about the future of beekeeping, right? And I really do think it's in genetics. When we started this project in 2018, I didn't know of anywhere to get, mite resistant bees in quantities. I was like, I don't know, all the treatment-free beekeepers lose so many bees, they can't even provide 300 without a huge amount of advanced warning. And the way granting works, we only found out like too late to make, for that person would have had to make plans a year before to help us out. But if I were doing it again, I would absolutely look for, probably varroa sensitive hygiene, BSH bees right off the bat. We did not do anything with these bees to see if they had resistance. But what I didn't tell you when I was saying about requeening with the sister queens is those sister queens were grafted from a colony that had not been treated for 7 years. So we thought it probably has some great mite resistance. It's not documented. But it was like living in the soffit of a house for 3 or 4 years. And then they did a cutout and put it in normal equipment. And 3 years later, that's when they made the queen. So we tried to get the best local that we could with some mite resistance, but we never, like I said, quantified that. But I do think the future is in breeding. One of the other projects that I'm doing right now, I got funding to teach beekeepers in the Northeast how to become queen producers. And then the cream of the crop there that are already queen producers are learning instrumental insemination. And my goal is to have like this army of skilled people for the future of breeding in the Northeast. And lots of people seem really interested in the program, and perhaps it'll get replicated in other areas of the country, but it's not for the faint of heart. We're very serious with our teaching. We have homework all the time. We meet every 2 weeks. We've been meeting for an entire year. And it's not like, here's how you graft, bye-bye, right? It's like how to make selections, how to keep data in your yard, we're making them read scientific journal articles to understand, royal jelly and egg development and all these crazy things. And some people have got scared off, but the remainers are like, I learn something every time, even the people that have been doing it for decades. So it's really fun. I have high hopes for the future. Someone asked about the queen breeding education in the Northwest. I don't think there's any other program like ours, because it takes like a dedicated extension person. Like there's not a professor that's able to spend that time with people. So I think our concept is new, this deep long-term learning, and hopefully others will repeat it in the future.
No, Robyn, there isn't here in the Northwest. There's a couple of queen breeders still in our states, in both Washington and in Oregon. Some of them start in California, start earlier in the season in California and then continue up here. We've had associations in both states, in both Washington and Oregon, of people that have that interest, and neither of them are functioning right now. They were led by dynamic people that kept the group together for a while, but they've now fallen by the roadside. So no, there is nothing at all comparable.
Yeah, my hope is that, I don't have to be the only energy that is stringing people along, that will get like, we'll pass it down and have train the trainer programs, they're called, where you're like, it's not like how do you do honeybee colony management, organic honeybee colony management? It's like, how do you teach other people how to do organic honeybee colony management? So I would love for all the clubs in Pennsylvania to be teaching that. Like, it's not rocket science. You just stay within some rules and give some people some hands-on experience. So I hope to,
Yeah,
it's,
certainly true for the basics. Absolutely for the basics.
yeah,
But then there are local, there's enough difference, even Eastern PA and Western PA that they could benefit from, forming subgroups after they get the basics.
yeah.
I had another question. You had commercial beekeepers as part of this study. Did any of them, do any of them before the study use organic treatments like thymol or any of the acids, or were they primarily using the synthetics? And if they did use synthetics, did any of them, based on your results, kind of switch over to something that's a bit more organic and not synthetic?
So you're talking about the conventional versus
Correct.
organic. I definitely think that a few chemical-free switched to organic, because I think they saw, like, if you take them out to the yard and you do varroa washes and they see for themselves, they kind of switch over and think, oh, maybe I should at least monitor and do something. I do feel like a little bit of that happened. I should probably survey them all again and see if anyone stopped using synthetics. The organic people were real happy. They were like, ooh, now I can, I was right. And they can hand out the paper and show people. But yeah, I really need to ask them that again.
Yeah, because when we first started beekeeping, we were really wanting to be organic and things, and they last about maybe 2 good seasons. By the 3rd year, they just peter out, and we started treating with the.
Wait, you don't mean organic, do you? You mean treatment free?
We were treatment free first, trying some, dusting with powdered sugar and that kind of thing, or drone removal, but we didn't put anything into the hive. And then we started using the Apilife bar, and it worked. We had a lot more survival. So it's not fabulous, and it does leave the smell in your colonies. So if you're going to be getting any honey, you're putting supers on for sure. Even dead outs, that we've had since then, it has a little bit of fragrance to it. So we mark our frames to make sure we know which ones were treated at some point. But yeah, it's a big difference.
Yeah, I think it's funny that when you first started talking, you said you started off organic, because people think that organic means treatment free, and it does not. So that's like my hardest education right now, is because people even saw the title of the paper. They were like, what? You're misleading us. And I was like, no, organic does not mean treatment free.
Right. It's kind of the vernacular grocery store, because organic means whatever for produce. So they kind of.
It doesn't mean that they don't ever spray, though, either. Right. Right? There are chemicals that are allowed and other ones that are not, but it's not without chemicals. So yeah, it's interesting. I don't know who made that seem that way first, but well, it seems like the questions have ended.
All right. Well, Dr. Underwood, thank you so much for tonight. And we appreciate you making your resources available for us. And it was great.
Happy to share. Thank you. If you need links or anything, let me know. I can email them to you and you can send them out to the group.
Yeah, I think we're going to be posting. Richard has taken those links, and we'll probably post those alongside the video when it becomes available on YouTube.
Okay,
So
great.
that's great.
Thank you.
Okay. So I'm going to take control of this screen again, if I can. Okay. Glenn, are you ready to give us our pollen and nectar report for June?
Yes, I sure am.
Shall I share this screen with you? Or
Should I share the screen? Is that what I do here now?
yeah, I'm a little bit confused. I think I
Let
need
me-
to make you a host. Is that correct? I'm going to do that real quick. Here we go. Glenn, I'm making you the host. And so, well,
Okay, looks like I'm sharing.
yeah, so I'll stop my share. Okay, there we go.
I want to start. Start from the beginning. Well, it doesn't look like I'm
Well, I can see your screen, but it's not in slideshow mode.
right. So I need to. No, that's normal. I want to go to here.
Yeah, I think that's it. There we go.
Okay. Blast off. Well, we were talking, well, I wasn't. Many were talking about how the smoke affected the bees when we had some smoky situations here a couple of years ago or so. I'll just add one thing to that. I noticed that they went through a lot more honey stores, and I actually had more starvation. I wasn't expecting it, but I had a few hives starve that I didn't think would do so. And I also put in this slide here that didn't have to deal with the smoke, but had to deal with the heat that we had. And I've shown this slide before, but I just find it quite interesting as to what actually happens or happened with the honey production, in that it ceased, to put on any major amount of honey per day. This is daily. Well, I only put down certain days, but you can see after the June 28th, when it was the high point there, that the weight just went down considerably and never really recovered. Now, one of my hives is on a scale. That's how I know this here. And usually it starts petering out, the second or third week of July, but it's still increasing there July 1st or the first week in July, but not this particular year. And the hive that I have now that's on the scale, they're putting on, it's not as much as I thought it might be, but yesterday was 2 pounds, but it's been 1 or a half a pound per day. It's really fun to have that, the information there, let you know what's happening. Okay. Well, I thought this might be kind of fun too here. Just my rules of thumb. People will always ask, when do you add a box or something like that? Oops, let me go back up here. And so my rule of thumb here is that in April, if there's any honey, just one cell full of honey, I put on another one. It may be just, that's just my rule of thumb here. And in May, if there's any white comb, which means they're, of course, really have nectar production on their mind because they're drawing out comb a lot. And then this month, if there's any capped comb, I'll add another super. Because if they're capping it in the middle, then they're probably working everything to the sides of the box. And so I've got, I don't know, half a dozen or more with 4 supers on now too, but I'm going to hold off on that to add any more. I mean, we're just now coming into the wild blackberries. So. All right. Well, as I mentioned, or as you saw on the slide, this is just for the 4 months here for June, July, August, and September. And so, you know, some of the photos, of course, that I'm going to be showing you here today are not blooming now. But that's what we've got. The poppies are popping and have been. They can really bury themselves in there going down for the mother load there. Zinnias, I haven't seen any zinnias blooming yet, but they will, and quite attractive to honeybees. You know what, at this time of year, well, not right now, but in July, August, September, that's a very important part for bees building their stores. So pay attention to that. Unfortunately, we'll see a lot of trees that are blooming in these latter months here too. So the native asters, they'll spread, but they're easy to pull up, and the roots will come up too. So put them, as I've mentioned many times on this slide here, that this was my neighbor's house that before it was sold, I went over and did a little planting of my own. So now it's all filled in there too. Another type of aster, but it won't be until September. But still, a nice little tiny aster. You know, the head is, you know, about the same size, a little bit bigger. The head is a little smaller than the blossom there too, but one of my favorites. Red creeping thyme, if you have a moist place, doesn't seem to need a lot of sun. It's nice to put in something that you could walk on, that the bees would like to. A lot of salvias coming up. I have this mullein here, both in the perennial category and also the weed category. But and I've noticed that there's several different types of these mulleins too, and some are particularly good plant, but I don't know the difference. I haven't researched that part of it yet. Sedums are coming out now, or will be coming out very shortly. Nice. My echinops are they're showing a little blue, but they haven't really opened up yet, but they're coming. One of my favorites. I wish I had a lot of those. Same with Joe Pyeweed. And of course, if you plant Joe Pyeweed, you're going to have more of it, but my patch has not expanded more than 6 feet, or would. I pull some up or whatnot, but in 25 years. So it's not a big weed. I like bulbs because, you know, you plant them and they just keep coming back most of the time anyway. Near these fall crocus or the colchicums. And many different allium species. I was just introduced to this one a couple weeks ago. I delivered some bees to a flower farmer, and she had these out there, and she had other alliums too, but this one was the biggest attractant of honeybees too. This Schubertii. Oh, I misspelled it there. Should be 2 eyes there at the end. Very unusual looking too. I like that it's called the common name is a tumbleweed onion. The dahlias are, I just saw my first dahlia has opened today, but if you keep them watered and deadheaded, they will reward you with many plants or many blooms, and they'll go until frost, which is November. So that's a pretty good run, 5 months maybe. This little guy does very well without any water. And it's not a it's not a big spreader like the weedy oxalis that we sometimes find, or oftentimes find in our gardens. Clematis will begin blooming if they haven't already. Mine hasn't, but unusual color and shape for a clematis. Point this out, you notice the purple pollen. I just think that's great. Hardy fuchsia also, what, 1, 2, 3, 4, 5, 6 months it can be blooming. I don't think it's real attractive to bees this time of year, but when the choices when there are fewer choices, then they'll certainly visit it. Quite a few food plants coming into bearing now, so to speak. Most fruit trees are done. Artichoke here. Quite a few. Spot all the bees. Fennel is listed here and also in the weed section. It's on the Portland nuisance weed list because it seeds so readily. But the bees like it. You let any of the brassicas go to seed, they'll visit it every month of the year as planted. The squash are just starting to blossom now. I've seen some. Mandy sent me this some years ago, and it's like the bee just doesn't know what to do. Crepe myrtle, they'll visit it. There's just not a lot of choices when this is blooming later in the fall. So it's nice to have it. My Aurelia spinosa here, cousin of the native devil's walking stick. This plant can hum with bees. Beautyberry, it'll go on to form those beautiful or very colorful, bright berries. This Japanese holly, maybe you read, I started doing a little column in the, or not a column, a little, well, it might be called a column in the bee line about just one of my favorite plants for the month. And this was my favorite for this month, just a very utilitarian plant, really. It's got nice leaves, it's evergreen, but it has these blooms that aren't very big, but very attractive to honeybees. White Gila has a nice scent too. Vitex, a wonderful plant. Not a, it doesn't bloom very long, but long enough, and they visit it. They're on it all day. The BB tree, just a wonderful tree, wonderful, and blooms when we want it to bloom. There in August when many other things are drying up there too. The Tilias will be starting soon. Maybe they already are in your neighborhood, but this makes a wonderful honey. Golden rain tree has, I haven't seen any blossoms open up on this yet, but it's kind of early in June too. American chestnut doesn't really have any nectar to speak of, but pollen, just lots of pollen. It also kind of has an acrid smell. Here comes my cat. I smell it in the neighborhood and I say, yeah, that reminds me of summer. Tulpa. And cross of the Tulpa here with this desert willow, which I'm not familiar with at all, but I've seen quite a few of these now around the neighborhood and parking strip. Silk tree. Another one of my favorite, very small tree here, the 7th sunflower. And you can just see the number of bees on this plant. It's only bloomed 1 month. I have it down for July and August. I think it just depends on the weather, but it doesn't bloom for a very long time. But boy, that's just a great time to have lots of blooms. I've scoped out in the neighborhood where they are. I know where 3 are around my hood. Herbs are good for what they are. I mean, there's just not a lot of them around, but it's nice to see bees visiting them. Beautiful photograph from my neighbor, Michael. Russian sage is a great bee plant, but it can spread. And it's not real easy. I mean, you can break them off, but it will spread underground. So be wary of that. As is mint. If you cover crops, will be blooming at this period here. The Cilia is a good one. Buckwheat, real short grow time from seed to flower, maybe 30 days. Makes dark honey, crystallizes quickly though. And finally, weeds. We've got the Armenian blackberry, the Himalayan, renamed Himalayan blackberry. There's that mullein again. Dutch clover, perennial. Dandelions, another 12-month of the year. And thistles. Certainly invasive, but good for honeybees. Lots of things are. These are posted at the Bridgetown Bees website. And if you see any plants that I don't know about or don't have any photos of, please consider sending me a photo. So that's my story. Thank you.
Well, thank you so much, Glenn. We have just a couple questions. What kind of
good.
scale do you use to weigh your hives?
Well, it's an old platform scale where you, like if you go to the doctor's office, you get up onto the platform and then slide the weight, and then there's at the other end there's another weight that I put on 100 pound or 200 pounds or 300 pounds even sometimes. So it stays outside year round, but it's all mechanical. So I suppose at some point it might rust, but
It'd be nice if you could include a photo of that at some point.
oh, that's a good idea.
Yeah, that'd be great.
I'll make a note of it here.
Yeah. One more question. How long does the blackberry flow last?
Well, it depends. You know, I've seen open blossoms now, but you go to the as you go out from the Portland area, either side towards the coast or towards Mount Hood, it's later. But even within the metro area, I think it can last, you know, it depends if it's in the sun or in the shade and whatnot, but it can last a month.
Okay. One more thing. Could you put your rules about when you add a super back up on the screen for us just for a second? We had one member that was interested in seeing that again.
Guess that's right at the top. There it is. You know, there's no scientific or anything, you know, it's just helps me when I'm adding supers, since I add more than 100.
Excellent. Okay, great. Oh, we're just having buds showing on the, I'm assuming on the blackberry in Corbett right now.
Uh-huh. Yep. Mm-hmm.
That's great.
Yeah, if they're in the sun, they're going to bloom sooner.
Yeah.
But
Okay.
I kind of like it when some are in the shade, because that means that you're just going to prolong the overall bloom.
Right. Right. Okay, great. Well, Glenn, thank you so much. Appreciate that.
Happy to do it.
All right. So we have a little bit of time left for anybody else that has some general Q&A for our for people here. And it looks like Dewey is still here, so we have a someone that can answer questions, and there's a lot of other members here. Are there any questions from people? You can come on audio and ask anything. Okay, well, then I guess that will conclude our June meeting, and excited to see you at the event on the 10th. And you can get all this information at our website, including the link to the video of Dr. Underwood once we get that posted. And thank you so much. See you again next month.
Good meeting. Yeah, enjoyed it. Next month.
Okay.
It's a little bit later next month. It's a week later than the first.
Oh, that's right. That's right.
Yeah.
We did
Okay.
that because of the 4th of July.
Because of the 4th, right?
Yep.
All right.
Thanks, everyone.
Okay. Thank you, everyone.